So in this video, I'll be going through the Set 3 Express Pure Physics Term 4 2022 paper. So this is the last question, question 7, and I'm combining knowledge from kinematics and forces into one question. So here I have a spacecraft falling back on Earth. When you have an object falling, it is a one-dimensional motion because you can only either go up or you can either go down, right? So as I have covered previously, how do you assign positive and negative direction is that you look at the initial direction of motion. So since the aircraft is falling down towards the Earth, I will take it as I will take downwards as my positive direction, right? So here in the speed time graph, you can see that in A to B, the object is speeding up, and then B to C, it slows down, and from C to D, constant speed. So in A part 1, I have to name two forces acting on the spacecraft, and I hope that just by looking at this, you would know. In fact, for my class, everyone got this correct, so I'm not going to cover much. But you need to spell it out in full. For me, I will just write the short form. So it's weight and air resistance. In part 2, what I'm trying to ask, in fact, is that I want you to compare W versus air resistance as the object is moving from A to B. Okay, but due to a lack of foresight, I realized that some of you actually interpret the question as at A, how will the force look like? And then at B, how will the forces look like? Like things like, oh, at A and B, the weight is going to be constant. And then A, because the speed is lower, the air resistance will be lower. At B, the speed is higher, so air resistance is higher. Actually, that is not my intent, but I give it to you. It is my fault that I didn't tighten the interpretation of a question. So the original intent for you is to actually compare these two forces, W versus air resistance. Which one larger, which one is smaller, and or if not, are they the same? So to do that, and why do I say that that's my original intent? Because what I want to see is that I want to see whether you guys recognize that when the object is moving from A to B, the speed actually become larger, right? It increases. So because of that, it means that your acceleration is actually positive. And I want to see how many of you actually can, this is the thought process, right? So acceleration is positive, and I tell and if you are taught by me, I keep telling my class that if A is positive, what Newton's second law tells you, one of the most important information that Newton's second law tells you is that if A is positive, F net is positive. If A is negative, F net is negative, right? So in this case, A is positive because it is speeding up. It means that between A to B, your F net is also positive. And because your F net is given by, is it W minus air resistance? Or is it air resistance minus W? F net. Come, think. Right? I said at the beginning, right? Let's take downward as positive. So W should be positive, and your air resistance should be negative. So in fact, your F net is given by W minus air resistance, right? So if you are able to come to this step, and since my question over here is asking you to compare the size of W with size of air resistance between A and B, if you have worked out to this point, you know that my F net is going to be positive. You know that my F net is W minus air resistance. What can you say about the magnitude between W and air resistance? Which one is larger? Is it like that or like this? Right, so to have a positive value for F net, I hope you can see that W must be larger than air R. So actually in your part 2, A part 2, I'm expecting the answer to tell me that W is larger than air R, right? And you don't need to provide any explanation because the question didn't ask you to explain. I just asked you to compare, and I give you only one answer line. For B part 1, you are asked to describe the motion between B and C. And if you are being taught by me, I keep telling my class, when you are asked to describe motion, don't give me fanciful things like some tuition center will tell you to describe it as velocity is changing at a certain rate, increasing rate, decreasing rate, constant rate. No need. For me, I just want one noun, one adjective, and then one noun, one adjective, right? So between B and C, if you look here, this is B, this is C. Definitely you can see that the speed has dropped, right, from B to C. So I know that here the velocity must be decreasing, right? And if my velocity is decreasing, it means that I'm undergoing a deceleration. So I won't be talking about acceleration already, right? So this deceleration, how is it moving? I need to look at the gradient, and you can see that at this point, my gradient of the tangent is pretty steep, and then when it approaches C, the gradient is actually becoming more and more gentle. So if your gradient is becoming more and more gentle, it means that your gradient is going to decrease. So here you would have to tell me that the deceleration is decreasing. Okay, so that's how you go through the process, right? So first, I let me recap for you. First, you look at how velocity changes. If velocity is rising, right? If velocity is rising, then you should pick acceleration as the next term. If your velocity in our case is decreasing, then deceleration. If your velocity is constant, well, then it's up to you, acceleration or deceleration. Okay, then when you want to pick an adjective for either acceleration or deceleration, you look at the gradient on a VT graph. Not any gradient, but gradient of a VT graph. Okay, then for part 2, I'm asking you in terms of Newton's law, I want you to explain now. So explanation actually refer to what we have done over here, right? But this is for AB, so I want you to do for BC. So pause the video, follow the same logic, look at BC, how is the speed changing? What is the A? What is the F net? Then tell me W versus AR, right? So that will help you explain it. So pause the video, think for a little while, how to explain the motion for BC. Okay, now I share with you. I hope you pause it and not wait for me to tell you the answer, okay? Because now you're watching the video, no one is judging you. Try, okay? Because this question, I can guarantee you, is going to be either tested in your end of year, in your Set 4 prelim, or in your O-level question. Because the main idea of studying forces is to explain motion. So definitely we are going to ask you to explain why the motion of the spacecraft is as such, right? Why is it that it is changing like that from B to C in terms of the forces, right? So you need to practice. So pause the video. You have tried it, right? I believe you are. If not, please pause the video and try it. No one is judging you. And after you try and you watch the video again, if something is wrong, then you can ask me, right? You know something is wrong. If not, then you have to find out during end of year. Okay, so how do I explain? Well, I follow the same thing. So from B to C, what happened to my speed? Right? My speed actually drops, right? So if my speed drops, what does it mean in terms of acceleration? It means that my acceleration is negative. Correct? Because acceleration negative means that it is slowing down, right? It's a one-dimensional motion. So if acceleration is negative, this means that my F net is also going to be negative, right? And since now I already know that my F net is given by W minus air resistance, then I can easily conclude that between B and C, my air resistance is actually larger than W. That's how I get F net negative, right? So this is my thought process, and I just need to turn this into words and I can score points, right? So now I have to explain why the motion of the spacecraft changes as such. So instead of doing it this way, I should phrase my answer this way, right? I should say that, oh, this is the cause and therefore it leads to this particular change in motion. So in my answer, what I would do is quite straightforward, right? So first I would say that, well, between B and C, my air resistance is actually now larger than W. And as a result, because Fnet is given by W minus air resistance, now my Fnet will become negative, right? And because I know that Fnet is also equals to ma, it means that my acceleration is also going to be negative. And that is how motion of my spacecraft changed from B to C, right? That acceleration is negative, and so therefore from B to C, my speed slows down. Right? Done. That's all. Right? And for the last part, I'm quite glad. I think 100% of my class, I'm not sure about other classes, the terminal velocity, which at what time does it reach terminal velocity, and you can recognize that terminal velocity basically is when your acceleration is 0, where the speed is constant. So this is the time, right? From C onwards, the speed has become constant. Well, if you have a further question, don't wait until the very last minute.